My name is Madhav. I'm a senior software engineer here at Google.
And I'm Abhishek, also a software engineer with Google, focusing on gRPC. We are both very excited to be here to talk about some of the exciting things we have been working on recently, and that is
gRPC Observability. So here's the agenda. We are going to provide like a comprehensive guide to gRPC Observability, focusing on the tools and techniques that we can use for distributed debugging and monitoring. We'll explore the ecosystem, including the role of OpenTelemetry, but we'll also highlight what other critical tools are available. So our goal here is basically to give you like a complete picture of what you can achieve with today's gRPC's full observability stack. So we are going to start with gRPC's integration with OpenTelemetry. So OpenTelemetry is an open source observability framework. So it is a successor to OpenSensus and OpenTracing. I am not going to do a demo right now, but we have guides and YouTube videos set up, and we also have a code lab later in the day for observability. So if anyone wants to try hands-on, they can do it in that code lab session. So this is just like a sample, like very simple, minor code changes that you can do, and you will have all your data exported to any backend that has a supported OpenTelemetry exporter. For example, in Google, we have the Google Cloud Monitoring Exporter or Tracing Exporter, and then all your observability data can be displayed properly. So folks that are familiar with OpenTelemetry, they would know that OTel has its own RPC semantic conventions. By that I mean they have their own way of defining RPC metrics. But when we started the effort to support OTel with gRPC, we felt that the conventions were too generic and not specific enough for us. So any RPC system probably has some nuances that are unique to that system, and those ideally would need to be captured by metrics. So for gRPC's needs, we needed to be able to define metrics and traces that made sense for gRPC. So we used gRFCs. gRFCs, as Kevin told in the morning, right? They are our way of submitting proposals and deciding what we're going to do next. So we use gRFCs to define how gRPC's OpenTelemetry plugins would work. We added a bunch of metrics and traces that have already been implemented. We have an ongoing collaboration with the OTel community, and there are talks of gRPC helping with the development of OTel's RPC semantic conventions also. So the aim is to try to get out of the box observability for RPC systems. So there might be some sort of compatibility story also on the cards. Cool. So let's start with the new stuff. This is just a sample capture of OTel tracing. I'm sure most of you must be familiar with it. We don't have a user-friendly guide yet, but the gRFC is available for anyone interested. In brief, what this gives us is a lot of information as to what is happening in the life cycle of a request, right? So usually what we do is we sample some requests and we capture their traces. We will basically capture 1 in 10,000 or 1 in 100,000 depending on how frequently we want to capture, and the entire life cycle of that request is then captured as a trace. So let's say a user request reaches a server, and then that server calls another server, like there are multiple hops in that request. Then you would be able to see all that information in the same trace, like it would be stitched end to end together, and then you'll be able to see the timestamps and where it is getting delayed and all that information in the trace. So we had the gRFC for tracing approved and merged, and in the past year we have this tracing implemented in Java, C++ and Go. It is still in experimental status, but we are just trying to dot the I's and cross the T's. Once we are sure everything is stable, we have some tests running, we'll call it stable. Moving ahead, we also have like TCP traces instrumented in C++. So apart from the regular tracing that we have in Java, Go and C++, and in C++, we have additional TCP-level events also captured. So you can see that when the packets are passed to the kernel with a send message syscall, when they are scheduled, when they are actually sent, and when they are acknowledged. Along with this, we also get some stats like that gives us delivery rate, minimum round trip time, and retransmissions, congestions, and more. So as detailed, we do this by sending down control messages along with send message syscall to tell the kernel that we are interested in these timestamps. And we've used this feature quite successfully in our debugging efforts within Google to determine whether we are running into a network problem, or alternatively to rule out whether the high latency is caused by network trouble or something else. At present, though, this is only available, only feasible with C++ on Linux kernels. I'll hand over to Abhishek to take you through metrics.
Cool. We have covered tracing, so let's now transition into the world of metrics. They are a fundamental part of understanding the health and performance of our gRPC applications. Metrics are essentially how our services communicate with us. They provide the necessary visibility to monitor, optimize, and pinpoint bottlenecks between clients and servers. Think of them as an early warning system. They help you proactively find issues like high latency or error rates before they ever impact users. Let's dive into some of the metrics we have had from some time. On the client side, you'll notice two seemingly similar terms, per attempt and per call. It's a fantastic question to ask what differentiates them. And that difference actually explains why we defined our own metric semantics instead of just using the standard OpenTelemetry ones. Here's the breakdown. A single call from our client application might trigger multiple attempts to the server, especially when features like automatic retries or hedging are active. So, why are per attempt metrics only a client-side thing? Simply put, the whole idea of an attempt is client-centric. The client is the one with the logic to say, that failed, let me try again. From the server's perspective, every single attempt, even a retry, looks like a brand new independent request. The server's metrics are designed to measure each incoming request it handles, which reflects a per call reality. Now, let's switch gears and talk about some of the new metrics we have been adding. We have been busy rolling out a bunch of new metrics to give you a much clearer picture of what our gRPC applications are doing. First up, for retries and hedges, if you have used OpenCensus before, these will probably look familiar. We have brought the same great functionality over, so now you can track retries, hedges, and even the delay between them right in our new OpenTelemetry implementation. Next, let's discuss WRR and XDS. First, weighted round robin, or WRR, is a powerful, more intelligent way to load balance. Instead of just distributing traffic evenly, WRR allows you to assign a weight to each server endpoint. So endpoints with more capacity receive proportionally more requests. Our new WRR metrics like endpoint weights allow you to observe and verify this load distribution in action. This is crucial for making sure your traffic is being sent effectively across a diverse fleet of backend servers. I'm happy to report that these WRR metrics have been implemented in core, Java, and Go. Second, we have introduced a whole new set of metrics for XDS. If you are not familiar with it, XDS is the API for service discovery and dynamic configuration in gRPC. It's how your gRPC client automatically learns about and connects to your backend services, handles routing, and applies policies. Having visibility here is huge. Metrics like client connected and client server failure allow you to quickly debug configuration problems. You can now easily verify the client is connected to the XDS server and successfully receiving valid resource updates. These have been implemented in core and Java. Next up are the new sub-channel metrics, a big improvement for connection visibility. With the earlier pick first metrics that these replace, it was a bit confusing to have sub-channel metrics coming up as pick first, even if it was not explicitly configured as the load balancing policy. Also, there was no way to get the actual disconnection error with the metrics. Now you can tell the cause like socket errors, go away, connection timeouts behind a connection getting disconnected, which gives a much clearer view for debugging. Now I want to zoom in on two additions here I am particularly excited about. First, these outlier metrics. This was an awesome contribution from our friends at Dropbox. It's a perfect example of the community making gRPC observability better for everyone. So a huge shout out to them. Second is the new optional label backend service. So what does this actually let us do? It holds the name of the backend service you are calling. So imagine if you have one client talking to many different backends, this label is a lifesaver. It lets you easily slice and dice your metrics for each service, so you can see exactly what's going on with each one. Just a quick heads up, we are working hard to get all these new metrics into every gRPC language, but they might not all be there just yet. We are rolling them out progressively, so it's always a good idea to check your docs for the specific languages and see what's currently available. So with that, what's next for metrics? We want to go even deeper, right down to the transport layer itself. We are working on a proposal for some new TCP-level metrics that will help you understand what's really going on the wire. Right now, if you have a tricky network problem, it can feel a bit like a black box. These new metrics are designed to shine a light in there. For example, we are planning to add things like min RTT, which will give you a clear best case look at your network latency. And delivery rate to show you the actual data throughput you are getting. And this is where it gets really powerful for debugging. Metrics for packets sent, packets transmitted, and even spurious retransmissions. This will give you a super detailed breakdown of what's happening at the packet level, which is used for diagnosing intermittent, hard to find network issues. These are still in the proposal stage, so you can't use them just yet. Think of this as a sneak peek into where we are heading. With that, that was all the stuff we wanted to discuss around OpenTelemetry. Now let's look at some other tools we have in the ecosystem to supplement the observability from our hotel metrics and traces. Here's a very handy tool, gRPC binary logging. At its core, it's a feature that lets you record RPCs in a binary format. This is super useful for a few key reasons. It's useful for troubleshooting. When you are trying to debug a tricky issue, these logs can give you a perfect record of your requests, responses, and statuses, helping you find the root cause of a problem. But one of the most powerful things you can do with this is replay RPCs. Imagine capturing a log from production environment and playing the exact sequence of events in a dev environment. It's an amazing way to reproduce and squash bugs. So for configuring this, you usually have to set an environment variable as is being shown on the slide. And you can get really specific with this, telling it what all to log. One more feature with this is security. With logs, there's a chance of leaking encryption keys or sensitive data. Binary logging has been designed to keep this in mind, and it allows you to filter what you want to log. Another next tool is gRPC curl. Simply put, gRPC curl is a command line tool that lets you interact with gRPC servers. The name pretty much gives it away. It's a curl but for gRPC. This means you can send gRPC requests and get responses right from your terminal. Now, I do want to mention that while gRPC curl isn't a tool that's officially maintained by the gRPC team, it is incredibly useful for a few key things. First, it speeds up testing and debugging dramatically. You can quickly fire off an RPC to an endpoint and see the exact server response without having to write a single line of code. It's amazing for API exploration. If a server has reflection enabled, you can just point and ask, hey, what all services and methods do you have? It will even show you the exact request and response schemas. And finally, since it's a command line tool, it's perfect for scripting. You can easily integrate it into your shell scripts for things like automated testing or health checks. Here's a quick example of how you can use it. Next, I will hand over to Madhav to take you through a few more tools we have.
Yeah. Thanks, Abhishek. So we are now going to talk about channelz. So we've got this term called admin services that currently encompasses two services, channelz and CSDS, that is client status discovery service. So both of them are services that can be added to a server, like in the example shown on the screen. And once you have these services being served, you can query them using RPCs as usual. So channelz in particular provides information on channels, subchannels, servers and sockets. It will get you answers to questions like what's the state of my channel right now, and like give me all the recent events on my channel or subchannel, or my RPCs are failing, is there something wrong with a particular subchannel. So apart from like having channelz as a service, to make life simple as part of the gRPC ecosystem, we have a helper UI tool that fetches the data for you and presents the data in a nice and easy to consume fashion. So the images are taken from the blog itself that is linked. It is a really useful guide written by Yuxuan that shows an example how to use channelz and the UI tool. So you can see, all the channel, sub-channel data, everything is here. We can fetch it and view it and basically debug our services. Now we have a work in progress gRFC for channelz version 2, and the aim is to make channelz more generalized so that the relationships between various nodes is loose, and so that we can record more types of, not just servers, channels, subchannels. We can basically record more stuff. But this is still work in progress, so not a done deal yet. The next thing we want to mention is gRPC debug. This is a command line utility. It allows you to query processes running gRPC. How it works is that it just acts as a gRPC client and queries the services that is exposed by the application. As shown, the commands that it supports are channelz, health and XDS. So channelz, in case you are unable to use the channelz UI, you can just use gRPC debug. And health uses the health check service, so you can check whether the server is serving or not. And XDS you can use, that uses CSDS in turn, which is client status discovery service. So if you have an XDS aware gRPC application running, you can use this to check the status of various XDS resources, and you can also get the dump of the configuration. So I'll just show you some examples. Like you can see, we are querying health, and we are querying for XDS config in one place, and in the third one we are basically looking at the server's JSON. So using channelz to fetch the JSON. With that, I'll just walk through the future improvements or the roadmap that we have. So we don't believe we are there yet. As we continue to use gRPC, we come across shortcomings, and we are trying to improve our observability to try and address those. We are really happy that we are able to engage with the community and get feedbacks and ideas as well. And as a quick summary of what we discussed, this is our immediate roadmap of what we are going to get done in the short term. So we are going to get additional metrics. We'll continue to add more metrics. Specifically, this includes implementing the TCP-level metrics, as Abhishek mentioned. Tracing stabilization, we are working on getting the OpenTelemetry tracing implementation to a stable state. And latency, it's a profiling tool for core that will help you visualize and analyze the latency of your gRPC program, and it outputs the data in a format recognized by tools like Perfetto. So that's a brief overview of gRPC observability. Thank you, and we'll be around. If you guys have any questions, you can always catch up with us. We can chat about your requirements of observability, or if you have some anecdotes to share.